Yep. All right, first thing, let's talk about the formula sheet. What can be on your formula sheet? I'll say my same caveat as always. Just use this as a guide. You should always go back to the actual book and look up the formula and make sure you didn't see what I'm writing incorrectly. Because there's a lot of little mistakes. Like on the take-home quiz, a lot of you guys gave me the variance and never square rooted it, and you might have had the formula written down wrong somewhere or something. So that kind of becomes a problem. But this test is going to go all the way back to section 3.4 for one problem. And that would be the finding the quartiles, making the box and whisker plot, right? So what goes into making a box and whisker? There's really no formulas, truly. There's a 5-number summary. Right. Something about low through high. You get the lowest number. First quarter, second quarter, third quarter, end, right? So it's sort of like describing a basketball game. Starts, tip off, first quarter, end of the first quarter, second quarter, third quarter, and then the end of the game. Hopefully the Celtics win. So there's a number of formulas there. It's just you got to know how to figure out those percentiles. Then we go on to chapter 5, which is where we hit a ton of formulas. You got this guy here. And a huge concern for any math course in statistics is definitely somewhere where we're worried about this, is when do you do what? Somebody brought up there's so many formulas for the mean and so many formulas for the standard deviation, but it kind of gives it away. This one's definitely a giveaway. I've got to give you x and p of x in order to use a formula that's got x's and p of x's in them, right? Then you got that guy for the standard deviation. Okay, so those go together. So you make your formula sheet. You can't write any notes for yourself, but you can certainly organize your formulas cleverly. Right? So those two go together. What about the next thing we talked about in that section was binomial probabilities. So you got the probability of a binomial situation would be e to the x. I love it. This is a situation where the formula kind of gets in the way sometimes. It looks worse than it really is. This just says the rest, right? This is how many successes, so this must be the rest failures. Formula-wise, it's going to look ugly because it's trying to cover all situations, right? What's the mean for an NPQ problem? N times P. And the standard deviation? That's the variance, so then square root, cool. Awesome. So I call it an NPQ problem, right? Because that kind of hits home as to when to do it. You can only do it when you can identify a single percentage of success. This kind of problem is going to have a lot of probabilities listed. So that can't be a single P, then I've got to do it a different way, right? So here the kind of problem for this should jump out at you. 87% of people have been in a car accident by the time they're 30. If you pick 12 people, okay, that seems to be a P for the 87%, and then pick 12 people, that's an N. All right, and then they say, what's probably 7 of them were in a car? Okay, there you go. That's the NPQ problem. That's this kind of a problem here. They kind of jump out at you. There's only 2 possible things. They give you 1 probability. You pick several people. There you go. That's the kind of setup for a binomial. Let's see. So that's the end of chapter 5. Chapter 6, we got our old standby here. This guy's, we talked about a long time ago, and he keeps coming back up because he's a very important little dude. Obviously, it's important because I keep asking you what the hell it is. Every single test, I will ask you the same question, just about. What was the formula that goes along with this if you want to go backwards? I'm not laughing at you. I'm just laughing near you. Yeah.
And that's if you want a certain value, right? Like there was a question from Homer where it was like, give me the exact number that separates the 25th quartile.
Well, the exact part is not really necessary. It's just when you start with a percentage and you want to relate that to a raw score through a normal distribution. Now, let me say all that again. Because for this kind of problem, this is your classic z-score problem where they tell you, well, my IQ is 108. What does that mean? What percentage of people have a higher IQ than me? And then you can make a z-score out of that. You look it up, get the percentage. So that's, I need to make a z-score out of something. This one is when they say backwards. They say, well, what's the IQ to make you in the top 10%? Oh, they gave me the percent first. So I gotta look the z-score up and then work backwards to get the raw score, right? Everything's backwards then. So this is what I use when I ask you, like, find P11 for, like, IQs. Well, we're pitching the 11th percentile of IQs. So that's a percentage. The biggest mistake people make is they look up percentages as if they're a z-score. Because, again, percentages look like z-scores. It's evil. They say 89%, 0.89, 0.89, there, here's a number. Does it relate to anything? No. Too bad. So be real careful about what is it that I know and what is it that I'm looking up. What lives in the body of a z-score chart are probabilities, percentages. On the outside are z-scores. So don't look out here unless you know the z-scores. Oh, let's see, where am I at? Chapter 6. Oh, and then we got, so we got a whole bunch of stuff with this. And then we hit this here. When is it that you have to do this?
For a specific subpopulation.
Okay, not really, but it kind of tells you in here. When I take a sample of size n, and I ask about the sample means, I have to change the standard deviation, right? That's that last couple sections we talked about. Okay, cool. And just so that everybody understands this, that we didn't make it to 6.6 yet, so like number 6, part 2, subpart C would not be on the actual test, right? I said that last time, just to make sure you guys know that. All right, what do you guys think? Do you think that's everything? It sounds like, I think it's everything. I think we made it up all the way to the end. Now, if you look in the book, and just to make sure you guys understand, the official z-score formula for this situation would be x bar minus mu x bar over sigma x bar. Because now you're talking about a bunch of sample means, right? It really didn't change. It's still my data minus whatever the middle is divided by whatever the standard deviation is. Standard deviation happens to change because I took a sample, blah, blah. The z-score formula doesn't care. You just put whatever it is for that situation, you put it in. So I hate when they make it look like the z-score formula. It's different now. No, it's the same stupid z-score formula. Yeah?
So like, what's the giveaway? When I'm reading a question on the exam, what tells me that I'm going to be using that? I'm talking about a sample mean. That's the sample?
When they take a sample, so when they say something like you pick 30 people, what's the probability that their average age is blah? Okay, they took a sample, they asked me about the sample mean, I better do this. Yeah. And the whole idea is there, it should be a lot more difficult. It should be a lot less likely for a group of 30 randomly selected people to have an average age of 100 than it would be for one person chosen randomly to have an age of 100, right? That's still pretty unlikely, isn't it? But I would believe somebody, I went out and I ran into this guy, he's 100 years old. I'm like, all right, great, big deal. Somebody goes, I went out and ran into 30 freaking people, just randomly all over the place, and they were all 100 years old. Okay, that's kind of interesting, right? I mean, that would be less likely. That'd be really hard to do at random. So that's why the standard deviation gets smaller, so that it is less likely out there. Now the probability is way smaller, way out there around 100 years old. All right. So that's the formula sheet. That's all that could be on your formula sheet, unless anybody has any other suggestions on there. No. You got to know that. It is a formula, though, so what the hell. Some books even don't even use Q. So I'll be tutoring somebody, and I'll say, now, what's Q? And they look at me like, it's the letter after P. What's it got to do with this? Because some books use 1 minus P only. So if you want to put Q equals 1 minus P, great. You can do it. I do not want to see, I mean, people always get in trouble. I will take points off if there's stuff on your formula sheet that should not be on there. This is what can be on there. So it's very clear. I always love it when a student says, well, I didn't know we couldn't have that. This is what can be on there. Can't be any more clear. Cool. All right, so if there's no questions on that, if there's no other suggestions, what kind of stuff do you want to get into now? What do you want to look at? You want to do some, to me, like, assuming you kind of are okay with a problem like number 3. I will in a minute. But like number 3, really the whole purpose of number 3 is just to make sure you can use the chart correctly. Right? That's it. So if you're okay with number 3, I would definitely try number 5 if you haven't tried that already. It's a really good one because it's got everything in there that it could do to you, basically, on that kind of problem, on a z-score probability problem. Yeah. Say again?
What are you going to do with chapter 6 homework? Are we going to still, is it going to be due on the 6th if we don't finish the chapter?
Well, up through 6.5 is due. So if you're doing online homework, I just got to go in there and give you some more time on that section, but I just got to not forget to do that.
Online?
Yes.
Online?
Oh, yeah. Up through 6.5.
How would you know which one is up?
Because I can see, it tells me the dates you finished certain problems. I can see a lot of detail on my end.
Like what, 50% of the homework? So it would be like 50% of the homework?
I'm not sure what you mean. Through 6.5 would be a larger percentage of the homework. Okay, just make sure you get through 6.5 done, and you'll be fine. So that's you guys who are doing out of the book. You don't have to start 6.6 yet, unless you want to. Yeah. Where are we at? Which one? Oh, yeah. So if you guys are, some of you guys might be doing number 5. I'm going to look at that here in a minute. But here's number 4 real quick. So I want a z-score with 91% below it. And this is in a normal distribution, right? So how do I draw the picture first? So you make a normal distribution. Where would the z-score be, down here or up there? Up there, because it's got to have 91% below it. So that looks more likely to have 91% below it. Now here's the part where people are evil to themselves. I see people do this. And they know what they mean, but what's it look like now? It looks like a z-score. So what they do then is they look up 0.91 and they give me that. But that's an area, that's a probability. They want a z-score. I don't know the z-score. Always put areas up there. If you don't do it the way I ask you to and you still do the problem correctly, you still get the answer, that's okay. But I try to get you to do it this way because it'll keep you from making simple mistakes. Now, so where am I supposed to look that up? In the area, in the body of the chart, right? So 0.91 up in here. What's the closest you can get to 0.91 area? Yeah, because that's 0.9099. The closest I get to 0.91 is 0.9099. And if I look out, that's 1.34. Cool. So a z-score of 1.34 has 91% below it. That part of the question is done. Because that's all I asked for, right? Is everybody able to see that? Or forever hold your peace? All right. So what about the second part of the question? It says find the z-scores bounding the